Okay, so this is the next in our series of videos about Python programming. This one's going to be on chapters 6 and 7 in the Think Python book. We're going to start with a little bit about recursion, then we're going to move on to covering chapter 6 on fruitful functions and chapter 7 on iteration. When we get through iteration, we will have covered the basic building blocks of Python and can write pretty much any program that we want. So from here on, we'll be doing just more details and more efficient ways to do things, okay? So let me go ahead and switch to the shared screen. Okay, so the first thing we want to talk about, again, are these recursive functions. These happened in an earlier chapter, and there were some questions about that people have had, so I thought it would be worthwhile to talk about them a little bit. So at its root, a recursive function is simply a function that calls itself. Okay, so this turns out to be a very useful thing in many ways. Okay, so actually let me switch to the whiteboard to talk about this. Okay, so for example, you have to have functions that we're trying to model that can be done recursively. Okay, so let's look at the factorial function. That's the one that we often use when we're talking about these kinds of things. So a factorial function like 5 factorial can be defined as 5 times 4 times 3 times 2 times 1, okay? So that's the normal definition. Whichever number it is, you just keep multiplying it by 1 less until you get down to 1, okay? The reason this can be a recursive function is that we can rewrite this in the following way. We can say that 5 factorial is going to be equal to 5 times 4 factorial. Okay? So the 4 factorial is equal to 4 times 3 times 2 times 1. So when we write it this way, we can structure our program in such a way that we're going to call the factorial function with 5. We're then going to hold off on getting that answer by calling it again for 4, and then for 3, and then for 2, and for 1, and so on, okay? So that's the basic idea of what we're doing. So let's take a look at what this may look like in code. Okay, so in code, I've got a blank file up here. We're going to write a function for this. We use the def for that. Call it factorial. Send it some integer. We're hoping. We'll have to worry about making it an integer eventually, but for now, we're just going to assume that it is. Okay, and all we're going to do here, we're just going to return n times factorial of n. N minus 1. Okay? So we're just going to, again, if we send it a 5, if you send it on factorial 5, at this first step, it's going to return 5 times factorial of 4. Okay, then 4 does 4 times factorial of 3, and so forth, okay? So we can go ahead and run this and see if this works. We have this function set up in our main program. Factorial of 5. See what we get. Okay. So now if I save this, let's call it back.py, and then hold down the function key and hit F5 and it runs it. We see that we have a problem. Okay, so let's take a look at what problem that we have. Okay, that may just be going on forever, so let me see if I can find, whenever you're having trouble with your code, and apparently I'm still going on forever. I've interrupted it there. So the problem is basically, I'm getting a recursion error with a maximum recursion depth reached or exceeded, okay? So what this means for us basically is that when I call it the first time with 5, it's going to stop what it's doing, call it again with 4, then call it at 3, and then 2, and then 1 is where we want it to end, but we didn't say that. So it's going to call it at 0, and at -1, and -2, and so on. And then it's eventually going to run into the maximum that it can recurse. That means the maximum number of sessions or of function calls it can have open. Okay, so that's the problem there. So let's look at a stack diagram of this just to kind of get an idea of what we should be doing. Okay, so again, what we're going to have to do in this code is we're going to have to check to see when we're done. So actually, let's do that before the stack diagram. Okay, so let's fix our code. Okay, so in our factorial program, every time it calls, it gets called anew with n. Okay, we want to check to make sure here. When do we stop? We stop if n is equal to 1. Okay, if we get to 1 in our calculations, then we know we can just return 1 because 1 factorial is 1. Else, if it's not 1, we're going to return what we had before. Okay, so now if we do the factorial on 5, it should correctly give us the right answer. Okay, because it knows when to stop. Okay, and again, that's because 1 factorial is just 1 by definition. So save it. Let's run it again. Okay, it's restarting it. Did it do something? I didn't tell it to print out anything, so that could be a problem. So let's go back here and let's just put in a print. Here, whatever happens. Okay. Again, and we run it. It returns 120, which I believe is the correct answer. Okay. So now let's take a little closer look and do a stack diagram as to what's happening here. Let's do this with factorial of 3 just to make it a little less confusing. Okay, so stop this. Whiteboard. Okay. So basically what we're saying here, when we start our program, we're going to have, change this to a different color. We're going to have this box, okay, for the main area, and we call this underscore underscore main underscore underscore in Python. We don't see that much, but we'll see it later as we get more involved. Okay, we're going to call factorial the first time. Okay, when we call it the first time, n is going to get the value of 3, let's say. Okay, so we're going to then call it again on n minus 1, which is going to be equal to 2 in this case. Okay, and we don't have a result yet, so we're waiting. So our r here, we're waiting on. Okay, we don't know what that is. Okay, so when we get this step here, it's going to call this again. The factorial function gets called again. Okay, this time with 2. The n minus 1 is 1. Okay, we're still waiting on an r. Okay, we don't know about yet. Okay, so n is not 1 yet, so we call 1 more time. Now n's 1. Okay, so we know that we're done, and we know that our result is equal to 1. Okay, so the 1 is going to come back into here. So we now know that our 2 times 1 is going to be equal to 2. Our result is equal to 2. Okay, so the 1 moved from here. The 2 moves from there. Okay, and our result is 3 times the recursive 2 factorial, which we know is equal to 2. So our result is 6. And now 6 is going to be passed back to the main. Okay, so that's how factorial functions are going to work. They're very easy to code, but they can be a little dense to look at. Sometimes when you're looking at the code, you may wonder what it is that exactly that's going on. Okay, so they do have their place but they can also be a little bit unwieldy. Okay. The other sad truth about factorials is that they're not as efficient as coding it in an iterative fashion. We'll talk about iteration in a minute. So these certainly will work for you, but they're not as efficient as they could be. Again, there's a lot of memory that gets created, or a lot of memory gets used up as you're putting all of these stacks on top of each other. Okay. So that's it for recursion. If you have more questions on recursion, make sure you let me know. And let me say again that we're going to be having a Zoom meeting this Thursday at 7 o'clock. Okay, so hopefully you'll be able to attend that. And basically just be watching your email, your Tusculum email, or whichever email that Moodle comes to. I'm not sure if you have a Tusculum account or not. I will go to Moodle and send out email to everybody with the meeting code. There'll be a link there that you can connect in on your computer, or you can connect in on a phone as well to be able to see what's going on with the meeting. Okay? So the next thing we want to talk about is chapter 6 on fruitful functions. And the book defines a fruitful function as one that returns a value. We've seen some of those before, including the factorial function that we just wrote, returns a value. Okay? Some of the early functions that we did just printed things out, so they didn't return a value. Okay? In this chapter, I think it's really important that you go through, I'm not going to go through it here, but you want to go through section 6.2 on incremental development. Okay? It takes you through the process of building a function step by step. Okay? And the incremental development is important in that you start with getting the biggest, broadest view of the code working, and then you add detail as you go along, checking your code along the way to make sure that it's working. Okay, so that's a good thing, definitely. Okay, the next section talks about Boolean functions. A Boolean function is simply a function that returns a true or false. Okay, so there's not too much going on there. Okay, the next thing I wanted to talk about in this chapter, and again, if you have more questions that I'm not covering, then make sure that you let me know. I'm just trying to hit the highlights in these videos. The next section that I want to talk about is section 6.8, which talks about testing to make sure that your variables are of the proper type. Remember that Python is not a strongly typed language, which means that you can have n be an integer and then reassign it to be something else. It infers the type from what's currently held in it. Okay, that can give us some trouble in our functions. So if we look at the function that's still on the screen here, the factorial function, if we would try to run this, 5.2, save this, run that, you see that we're again going to run into the problem eventually of it never ending. Okay. Okay, so that killed it finally. Okay, so again, the problem being that it'll never hit 1. Okay, so we need to add some extra insurance here to make sure that we're not going to have a problem. Okay, so we can start here by using this new structure. We can say if not is instance in int. So we're going to ask the question here on this if. We're going to say is in an int. Okay, in fact, we're saying if not, if it's not the case that isn't is true, okay, then we can give a message to the user. We can print out an integer. Okay. Then we're going to return from our function none. Okay, we don't want a value at all. Okay. We can then go on into the rest of our program. Okay. While we're checking, we also want to check to make sure it's not a negative number. Okay, so I can come down again and say an elif n is less than 0. greater than 0. Okay. So then this if becomes an elif. Okay, so every time this function hits, it's going to check to see if n's an integer. If it is, it moves on. If not, wait, oh no, these are not good. These are not the same thing. Because if it's not this, well, they may be given to. I have to think about that one. If it's not an integer, it's going to print out that error message, return none. Else, if it's less than 0, it's going to print it must be greater than 0. And again, here we need to return none as well. I think I know it. I think it's okay. Else, if n is equal to 1, we're going to return 1. And if none of these conditions are true, then we call the next version. Okay? So if we call it here with the one we know should be an error, okay, it's going to say that it must be an integer and it's going to return that, which is what we want. Okay? So if we correct that, let's actually try all the other possibilities that we have. Negative, and we see that it must be greater than 0, so it looks okay. And then finally run it with something we believe is correct. We that, run that, and the answer is 6, which is correct. Okay? Okay, so again, when you're writing your functions, you want, whenever possible, to make sure that you're getting track for any likely errors that people are the errors that people are likely to make. You want to try to stop them in advance. Okay, so that's definitely something to consider. Move on to iteration. So iteration just means we're going to do something over and over again. Computers are very good at doing things repeatedly. It's one of the things they can do that we can't. It's sometimes difficult when we're trying to put together an algorithm for a program, in that we will try to do it like we would do it. We would using our brains. Because we don't want to do things over and over and over. Where a computer has no problem just brute forcing things by repetition. Okay, so definitely we can take advantage of that. We have to adjust our way of thinking for a little bit. Okay, so the first kind of statement we're going to do here for iteration is called a while loop. So a while loop allows us to continue to do a block of code. So it's a block level command. It has a colon at the end. So all the statements that are indented over, remember Python's crazy about indentation. All of the statements that are indented over are going to keep going until whatever logical condition happens after the while becomes false. Okay? So this is how this, so let's say like, I've got while I have no example for you guys. Okay, let's say int, we don't say int, wrong language. Let's say x is equal to 14. And I can say while x is greater than 0. Okay. I can print something like that would be the basic idea here, okay? And then over here, say, okay. So as far as the flow goes here, once you enter the while, it's going to check to see if this logical condition is true. And this logical condition can be a greater than, less than, equal to. Remember the equal to is 2 equal signs. Any of that stuff. It could also be a compound with this and that, whatever. Okay. So while this condition is true, the flow of execution goes into the loop. As soon as this condition becomes false, we're going to move down to the first line that's not indented. Okay, so we can do this as many times as we want. So we can have other lines here. You know, we can print hello, whatever you want to do. Okay. So anything that's indented is going to keep happening until this condition becomes false. Okay. So it's important, we haven't done this yet, but it's important that inside of the loop, okay, so in this indentation area, we have to be moving toward the terminal condition. In this case, the terminal condition is when this x greater than 0 is not true. So when x is equal to 0 or x is less than 0. So we have to be moving toward that in our while loop, okay, or we have what's called an infinite loop. So in this case, if we would run this, it's going to, x is equal to 14. 14 is greater than 0, so it hits this line here. It prints the 14. It prints hello. It goes back up to the y. Okay. X is still 14. X is still greater than 0. It prints 14 again. Then it prints hello. And then 14 and hello. Forever and ever and ever. There's no way for it to move toward termination. Okay. If your program does that, then pressing Control-C or Control-D, one or the other, should stop it from going on and on and on forever. Okay, so what we have to do here, we have some options. The simplest way, I can just reset x is equal to x. Okay, by doing that, x is 14, 13. It will eventually get to 0 and will kick out of the loop. You could also ask the user for the number. We haven't done that yet, but you could. There are many things that you could do. You have to have a way to be moving it toward the terminal condition. Okay, so let's run this one here and see that it does count down from 14 down to 1. 1's the last time. So let's look at that last time. When x is 1, we check to see if x is greater than 1. That's true. We print out x, which is 1. We print out hello. X now becomes 0. And there's no more. So when we get to this point now, is 0 greater than 0? It is not. So then we would print out the VOB at the end. So 1's the last value. Okay. There's an off by 1 error that occurs frequently in programming, especially when it comes to while loops. Okay. If you want to count down, if you wanted to count down to 0, then you would have to change this true to while x is greater than or equal. Okay. Or sometimes you go a little too far one way or the other. So you have to make sure that when you're counting, run it through and test it to make sure you're not going one too many or one too few. That's a really common error in programming. So you have to want to check those out. The other thing that you can do, sometimes you'll have a loop where you don't know when it's going to end, okay, or you have a condition that happens that means that you want to end immediately. Okay, so let's just say that no matter what we're doing here, that if for some reason x is equal to 10, okay, so the break command means whatever you're doing, stop, exit from that loop. Okay, so if we run this, either goes 14, 13, 12, 11. When it hits 10, when it hits 10, then it's going to enter into this if statement. The break is going to take it outside of the while, take it to the first line outside of the while, which is the VOB will be printed like it shows over there on the left. Okay. So that's the while loop for now. There's some other things that we can do, different kinds of iteration loops, but anything you can do with others, you can do with a while. Okay, so the while will certainly get us started. Okay. So the other thing that we're going to talk about at the end of this chapter, we've mentioned it a little bit before, it's just the idea of an algorithm. An algorithm is nothing more than a step-by-step way of solving something. Algorithms have to have a couple of characteristics. They have to be unambiguous. They have to be where they always work no matter what the input is. Okay, so again, that's where we don't always think algorithmically. We can see if something's going to go wrong way before it actually goes wrong. Okay, so we have to tell the computer in very specific terms. Computers don't know anything except what we tell them. Okay, so it goes through the example using was it's Newton's approximation. Is that right? Yeah, Newton's algorithm to approximate for the square root. Okay, so you should go through that example as well to give you a better understanding as to what's going on. Okay, the other thing to say is that you have to be able to solve a problem on paper before you can program it. Okay, so in this case, if you just know that the square root of 4 is 2, it's not sufficient to be able to write a program. You can't write a program, or you shouldn't write a program that's just going to have to remember what the square root of every number is. That's not possible. There's an infinite number of numbers. Okay, so that doesn't work. So you have to be able to have a way to calculate the square root in an algorithmic, repeatable fashion that doesn't require knowing the answer when you start. Okay, so that's again the example of the Newton's algorithm. It's one way to do that. Okay, so that's it for this video. I wanted to just to touch base again. I know that all but I think 3 of you have got through the first chapter homework. And just in case you're nervous about things, the homework should be done by whenever we have our midterm, which comes up. It's a long way from now, it seems. I'll have to check those dates. But I know that your schedules are variable and that you're busy a lot of times. So I'm not, even though there are due dates for homework, there's no penalty at this point for not getting it done. The big thing is if you're stuck, I want to know about it. If you haven't had time, that's fine, no problems. But if you're actually stuck and not making progress, then I need to know about it, okay? So remember the meeting on Thursday of this week, okay? So we'll be able to talk a little bit face-to-face. It'll be at 7 o'clock. I will send you an email with a Zoom invitation in it, okay? That or I may post it on Moodle. So definitely get onto Moodle at about 7, and you should, that's probably the easiest way rather than emailing. So I will post it on Moodle. You'll be able to get to it that way, okay? And if you're having trouble, send me an email and we'll figure it out, okay? I think that's all for now. There was a question, I guess we talk about that. Somebody had questioned in the book on the print statement, you can do this end equals, that meant, what this means basically, a print statement by default, although it doesn't say it, going to do this, where the \n refers to a new line character. So if you print something out, it's going to print it on its own new line. It's allergy season. So let's just take a look at what this is. So again, if I print things normally, I can print Bob, and we'll just leave that normal. Save this and run it. It prints Bob on one line, hello on the other. Okay, so it's assuming that when it's done, and so again, if I run this, it should do exactly the same thing, and it does. Okay, but if instead I wanted it to stay on the same line, okay, I could do this. I could do n is equal to a space. Then it's going to print Bob space hello. Okay, and that's all that's doing. Okay, in fact, you could probably, although it may blow up, you could put a plus sign in there if you wanted. If you want to put a plus sign there, let's try that again. Do that, as weird as it seems. And I assume that's probably okay. So that's just a function or a parameter of the print function that's saying that when you're done printing this line, what do you do? Again, the default, which you don't have to put in, is a new line character. Okay, I think that's it. I know some people have had some questions about the homework from chapter 4, chapters 3 and 4 both. So we can talk about that on Thursday, and after more people turn that in, I will try to put a video up that may address. So if you have questions, definitely send me an email. Okay. So I think that is it for now. So I'm going to stop the recording and